Hi all. Today we are going to discuss the problem based on the node voltage analysis or nodal analysis method. Okay. So the problem is the calculate the currents in all the resistances of the circuits shown in the figure using nodal analysis. So this is the circuits here given here, and if you are going to do a problem based on the nodal analysis, the first step is to find the number of nodes in the given circuit. Okay, we have to identify the number of nodes in the circuit. Okay, so as per the given circuit here, we can identify the number of nodes as the first node will be this is the first node. Okay, so we can name it as node A, and this is the second node, we can name it as node B. Okay, and we have to find a reference node also. Okay, we have to choose a reference node to which all node voltages can be referred. Okay, so here normally in most of the cases the reference node will be here. Okay, and we are keeping the reference node voltage we reference as 0 volt. Okay, 0 volt. Okay, so this is the first step. We have to identify the number of nodes. So in the given circuit there are three nodes, A, B, and a reference node. Of course in a circuit there will be a reference node. Okay, and we are keeping the reference node voltages as 0. Okay, and this is the circuit where we have assumed the node voltages and nodes and all. Okay, so here the first node voltage we have taken as V1. Okay, as per the figure, the first node voltage is V1 and second node voltage is V2. Okay, the node voltage is nothing but the potential of this point with reference to our reference node. Okay, that is in the early case you have seen that this is the node A. Okay, so V1 means the potential of the node A with respect to this reference node. Okay, V2 means this point with respect to the reference node. Okay, so here you can see this is a node, this is also a node, but all these two nodes are same. Okay, that's why we are keeping that as a reference node. Okay, in most of the cases these the below given nodes will be same. Okay, so three nodes are there, V1, V2, and the reference node. The voltage of node A is V1, and voltage of node B is V2. Okay, and in nodal analysis we have to find the node voltages V1 and V2. We are going to find this V1 and V2. Okay, after that only we can find the current through the resistances. Okay, so after assuming the node voltages and all, the next step, okay, the next step is to assign the current direction in each node. Okay, so here we are taking, this is the first node, and we are assuming that I1 is approaching here, and I2 and I3 currents are leaving from the node, and the second node also here I3 is approaching this I4 and I5. Okay, you can see this I5 here, the I5 in this side, this is a current source, they have given a current source here, but here it is a voltage source. Okay, so if the in the question itself, if they are given a current source, which means that this value of current, the I5, is itself 4 ampere. We need not to find the current through this branch again. Okay, it is already given. Okay, so it is given to help you. Okay, so the current I5 is 4 ampere, and it is better to assume the current direction of I5 as same as the current source here. Okay, so here the current source, the current direction is in this direction from bottom to top, Okay, so likewise, it is better to assume the current direction of I5 in the same direction as given in the current source. Okay, so after assuming the current direction and all, next step we are going to write the Kirchhoff's current law in all these nodes. Okay, all these nodes. So if you are writing the Kirchhoff's current law for the first node, we know that KCL gives the current entering the junction is equal to current leaving the junction. Okay, so here the current entering the junction is only this I1. I1 is entering, then the I2 and I3 is leaving. Okay, right. So we can write what we can write I1 is equal to I2 plus I3. Okay, I1 is equal to I2 plus I3. So this is the first node equation. But the main point here is we have to clearly observe that we are going to find this V1, right? Okay, that is the node voltage V1. Okay, V1 means the voltage of this point with respect to our ground. Okay, but here you can see this is the 6 volt source given. Okay, actually this 6 volt is it is applied across this 3 ohm resistor. So this 6 volt itself give the value of this V1. We need not to find the node voltage V1 by writing the KCL here. So this problem is a special case. Okay, we need not to find the node voltage V1 because the V1 is also given in the question itself. It is our 6 volt. Okay, V1 is equal to 6 volt. Okay, if there was a resistance in between them, okay, if there was a resistance of something, a 2 ohm resistor is connected in between this 6 volt and V1, then this V1 and 6 volt will be different. Okay, then we have to write the KCL for this node, Kirchhoff's current law for this node. I1 is equal to I2 plus I3, and using that equation and all, we have to find the node voltage V1. Okay, but here in this case, no need of finding that V1, it is already given in the question. Okay, so while we are getting the question, clearly observe the circuit well. Okay, so here the 6 volt is actually applied across this 3 ohm resistor. Okay, it is directly given here. Okay, no element, no resistor element is in between the 6 volt and V1. So the V1 is equal to our 6 volt. V1 is equal to 6 volt. Okay, so we have to write the Kirchhoff's current law KCL. Okay, KCL for the second node only. So here in the second node, we know that I3 is approaching and I5 is also approaching and I4 is leaving. Okay, so we can write current entering the junction is equal to current leaving the junction. So I3 plus I5. I3 plus I5 is equal to I4. Okay, so that is the KCL equation here in this second node. And we know that the equation for I3. Okay, equation for I3 is you can see here applying KCL at node I4 is equal to I3 plus I5. Okay, I4 is equal to I3 plus 5, that is I4 is equal to I3 plus I5. Okay, and I4 we have to write the equation. Okay, after writing the KCL, we have to represent each current in terms of the node voltage. Okay, that is I4, we have to represent I4, I3 and I5 in terms of the node voltages. Okay, that is V1 and V2. Okay, here V1 is itself 6 volt. So I4, equation for I4 is, listen carefully, I4 we can write I4 is flowing from the voltage node V2. Okay, that is from V2 to this reference node. Actually I4 is flowing from V2 to this reference node. So we can write the equation for I4 is, we know that current is always flowing from higher potential to lower potential. Okay, so we have to take the potential difference. So V2 minus V reference, because I4 is flowing from V2 to V reference. Okay, so V2 minus V reference divided by 12. Okay, V2 minus V reference divided by this 12. Okay, and we know that V reference value is 0, so we can write V2 by 12. Okay, so that is actually written here, V2 by 12. Okay, Then for I3, actually I3 is flowing from this V1 to V2. V1 to V2. Okay, so higher minus lower. So V1 minus V2 divided by 2. V1 minus V2 divided by 2. And we know that the value of V1 is 6. V1 is 6. So we can just substitute that 6 here. Okay, and also I5. So here the I5 is already given because it is itself 4 ampere. Okay, I5 is already given, so we can just substitute the value of I5 as 4. Okay, after that we have to solve this circuit and we have to write the equation in such a way that something into V1 plus or minus something into V2 is equal to a constant. Okay, that is our standard equation. Okay, by solving this V2, V1 and something, we know that V1 is 6 volt, so just we can substitute the 6 volt. Okay, and the only unknown thing is this V2. Okay, only unknown value is this V2. So from this equation itself we can find the value of V2. Okay, and we will get the value of V2 as 12 volt. Okay, so the V1 is 6 volt and V2 is 12 volt. Okay, it's already finished. So we need not to write the KCL equation, Kirchhoff's current law equation, at both the nodes. Okay, the reason is the V1 is already given in the question. It is 6 volt. Okay, so we have to write the second node equation. Okay, and we have to the question is we have to find the current in all the resistances, that is 3 ohm, 2 ohm and 12 ohm. Okay, so current flowing through 3 ohm is I2. Okay, I2. So for equation of I2 is V1 minus 0, that is reference, V1 minus 0 by 3, that is V1 by 3. Okay, so 3 ohm resistor is V1 by 3, I2 is V1 by 3, so V1 is 6, so 6 by 3, 2 ampere. And current through this 2 ohm, 2 ohm is I3, so I3 is equal to V1 minus V2 by 2. So V1 we know, V2 we know, just substitute and we will get as minus 3 ampere. Minus 3 ampere means actually the I3 is flowing in opposite direction. Okay, opposite direction here. And also the current in 12 ohm resistor I4 is what is I4? I4 is flowing from V2 to reference. So V2 minus 0 by 12, that is V2 by 12. So V2 by 12 we will get it as 12 by 2, 1 ampere. Okay, so the problem is finished. We have found the current flowing through each and every resistances, and the main thing you have to note down is you have to observe the circuit carefully. Okay, something in some questions there may be given some twists. Okay, so you have to find the actual value of this V1 and V2 carefully. Okay, so I hope it's clear. So thank you all.